Okay, welcome to another Compilate box. A few things have changed. You notice the surroundings are slightly different because I've moved house and moved in with my partner. Also, I'm sporting the wonderful Compilate box t-shirts. You can also get baseball caps, mugs, etc. And they're all available. There's a link on the compilatebox.co.uk website. So, a bit of an experiment this week. We'll be setting things up, and we'll be doing some lighting projects with an Arduino Uno. Now you can do it with any Arduino or indeed many other chips, but it's the Arduino Uno I'll be focusing on as a prototyping method. Main difference this week is that these LEDs are by all means a strip of 50/50 LEDs, but these are addressable, which means we can set any individual LED on or off. At the moment I'm in Blink program just to show that it's working. And the whole purpose of addressable is we can turn on any individual LED or LEDs individually or in a sequence or in blocks. That's a bit more advanced. And there are different types of WS2812 LED strips as well. The 2S812 refers to the chipset, and we require a couple of things to be set up slightly differently for this. The first thing that you'll notice is I have a power supply here. This is 5 volts coming from a normal brick power supply that'll supply 1.5 amps. That is going straight into the LEDs, and all I have done, there is no electrical connection between this end and this end. All I've done is I've wrapped tape round so we can fit it all on the camera. The other thing that you'll notice, so the red and white wires are plus and minus 5 volts because you can only draw about 600 milliamps from an Arduino, and it's not best practice. It does make a difference to the brightness of the LEDs. It does have a side effect that it's drawing power from 2 places, but this is only going to happen while we're programming it. You'll see what I mean as we progress. And then there's this 3-wire connector. The red wire is plus 5 volts, the white wire is 0 volts or ground, and the green wire is data. That green wire is connecting to this grey wire. And actually, I shouldn't have that one connected. You can cheat, you can actually power a small number of LEDs from the Arduino, but it is much better practice to not do it. So we'll have the ground connected, and we'll have the data wire connected, and the data wire in my instance is going to pin 7. You can pick a number of these outputs. You need to experiment and see what suits your needs. I chose pin 7 because that is what it was set to on the original program. I've tested all my connections. I know everything is going to work. So all we have to do is set up the WS2812 environment. Now, this uses a library, a C library. Don't be scared by this, it's really easy. All you have to do is go Tools and Library Manager on the Arduino library. And to find what new things we want to install, we can click Arduino and type in Fast LED. And this is the one we want. It's Fast LED by Daniel Garcia. I have it installed. All you need to do is click install and it will get the latest one. If you do have it installed already, you may have an earlier version and you can update that. This button will change to update. You can get the latest version. That's all you need to do. There's nothing to it. It's as simple as clicking the button. Once you've got them installed, you can just have a look. You can browse libraries by categories. You will also see it under Neomatrix. Now, I have both installed, but I promise you it's only Fast LED you need. The WS2812 libraries are also known as Neomatrix, but this is a much more up-to-date version, and that is the one I'm referencing in the library. So if we go to installed, you'll just see those. I know there's another one installed there that we're not using that. All will become apparent when I switch back to the right window. So all I'm doing in OBS Studio, I'm switching over which program I'm looking at, because I've got multiple programs running here, and I have to set up which one it captures. Just checking my audio. Yeah, still recording. Okay, so the first thing that we need to do on our program, and yes, for speed, I am going to copy stuff from an existing program. So, WS2812 programming. It's a demo program to test LED strips and matrices. We'll get to matrices in a minute. Having installed our fast LED library, we need to include a reference to it. So I've included the fast LED library in the first real program line. And now we need to set up some variables just to let the program know exactly what we're doing, what configuration we want. So the first one is to let it know the data pin that we're going to be using is pin 7. This is a lie, we're not going to program 256 LEDs just yet. And the brightness goes up to 100%. And the reason that I've set it for 10% is it'll blind the camera and you won't see much. So we'll run it initially at 10%. We can always turn it up to 100% later. It just makes it life easier for you guys to see what I'm doing. And the other one is the colour order. And I know it starts with the letter C, but that's just the way it is. So the colour order I'm going to define any of the parameters in is RGB. Then the next few things that we need to do, we need to program the strip itself. Tell the strip how many LEDs we're going to be using. So see RGB, and again you're going to hear this coming up a lot. It's a property of the LED strip. We're telling it that the number of LEDs it has to deal with is num LEDs, which is 20. Otherwise it'll try to send stuff off into the wild blue yonder, and you won't know what's going on. So we'll do a little setup first, give you guys a chance to see what is going on. So the setup part of the program is going to run once only, and all I'm going to do, again, you define this property fast LED, you define what chipset it is, what the LED programming pin is, and you program the GRB. Now I know I said it's RGB up there. The actual parameter you pass to the LEDs is in GRB format. It doesn't matter because all you're doing is telling it the LED that you want to address and how many of them there are. We're going to set the brightness property of fast LED to the brightness figure we've defined up here, which is 10, and then we're going to define an array of raw LEDs 25, and if I remember rightly I'm not actually using that, so we can take that out for now. Then what we do is we'll set a loop up to go from the first LED, which is 0, to the highest LED, which at the moment is 20, and each LED we're going to set to white. And there's a number of ways you can do it. I prefer the RGB format because I'm a web designer and web designers like working in RGB. You can do it by the name of the colour, you can do it in hexadecimal, you can do it a number of ways. All you have to look up is the documentation for WS2812 LEDs and the fast LED library. Fast LED show causes the data to be sent to the LED strip. And I've commented out a delay here. You didn't need it. The slow delay is to make it pause once all the LEDs are lit. After a short delay, it will then go round to the next part and it will extinguish the LEDs by setting their value to 0. So it'll start at the top LED and it'll go decrement down to 0. And it'll set those all the way down to black, which is 0, 0, 0. It'll send the fast LED show signal, which updates the display. I've took this delay out again, and then put a slow delay on the end. I will just run that, and if you watch the LEDs here, This LED is blinking because I've got the blink program running at the moment. It was just to clear, you get residual data left in the WS2812s. So I'm just literally running a different program to clear the data out of it. And this LED will start blinking like crazy when I upload, unless there's an error in the program. So there's nothing happening in the main program loop. It's just going to do setup, which is the initialize loop, and here we go. Any second. And you saw the data go in, and that's just set it to everything to 1, 0, and then all to 1. And the reason it's not working is because I've changed the format of the bloody program. Okay, so let's have a look at our program. I've changed these values because inevitably I've been trying something else out. So I set the fast LED to 100 milliseconds and the slow one to a quarter of a second, 250 milliseconds. So this is just going to define what chipset we're using, how many LEDs there are. It does say GRB format. That is just the way that you set it up in this environment. It will still take it in RGB format. This command isn't being used, I promise you. I've done a lot of testing of a lot of different programs before we get to this stage. So the first part of the program is going to start at the first LED, which is referenced as 0. It's going to count up to the number of LEDs, which is 20, and it's going to increment. Each LED's I, is going to set to 255, 255, 255, which is white in RGB format. It's going to dump that data signal into the LED, have a short delay, and then it's going to go round to the next one, and it will sequentially address each LED as it goes in. There's then a longer delay, a slow delay of a quarter of a second. It'll do the same thing in reverse. It'll start at LED number 20. It'll decrement all the way down to 0, one at a time. It'll set it to RGB 0, 0, 0, which is black. Then be a little, it'll send the data, have a short delay, then it'll be a long one, and it'll finish. This is just the initializing program. So I'm going to launch that for you now. It'll take about 5 seconds to upload the data. And inevitably when it finishes, you see the LEDs start and then go back to normal. Okay, so that's just our initialization, and the reason behind that is just so that you know all the LEDs are working. It's a predictable pattern that you can expect when you start it. So I'll do it again with a shorter delay on it. It's like when you turn your ignition on in your car and it flicks the rev counter up and back. So there you go, a little bit of delay on the webcam, doesn't matter. So we're now going to put some more programs in. And in the loop, I'm going to set up some patterns to run. The first thing we're going to do in void loop, all void means is that it doesn't return a value back. Okay, so we're going to establish values for the red, green and blue content of each individual LED. I've abbreviated them to RGB because RGB is nice and easy to say. And we're using a random function, very similar to what we've used in the other LED programs. And what I'm doing is I'm generating a random number between 0 and 15. Reason being, yes, you can set 255 levels, 256 if you include 0, for each of the RGB parameters. It's not really going to make a massive difference. If you do that, you'll end up with colours that are indistinguishable from each other a lot of the time. The random function isn't truly random, so we're going to exaggerate it a bit. So if this section here, then I can highlight the right bit, if this section here can be between 0 and 15, that is 16 steps. That multiplied by 16 will give us an answer between 0 and 255. Effectively, we're creating 16 steps that can be between 0 and 255. So they will always be at least 16 different in the count. It's possible to over-engineer these things and make it really complicated. We're then going to put in all this case statements that I've got, and I'm not going to go too much into detail with it, but all it does at the top here, I'm going to generate another random number called move. You could call it move, you could call it pattern, but this generates a random number between 0 and 6. So it has 7 values in total. And I've abbreviated what some of the patterns are called. So the first one, ignore case 0 for a minute, we'll come back to that, but program move 1 or pattern 1. If move is equal to 1, it'll do this, it'll go to the left. And left is an arbitrary thing because it depends which way you're facing the LEDs. But I just call the first one left. So we start at 0, we increment to num LEDs one at a time. We take our random values for RGB that we've just created, we send that value into the LED, we do the show to update the display, and we do a fast delay. It'll do it 20 times. So it'll do a whole pattern. It won't just move 1 pixel, it'll do a 20 LED pattern. Conversely, if move is equal to 2, it'll do the same thing the other way round. So it'll start at LED number 19 and it'll go down to 0. That's how you get your 20 LEDs. So that does the same thing, it will decrement using these random values, it will decrement backwards. Then we've got one called out that starts in the centre. And all we do to calculate the centre position is we take num LEDs, which could be 20, we add 1 to it and then divide it by 2. That just guarantees that we get 20 after we've halved it. We then use that to set one of the LEDs starting at 0 going up to 10. We then subtract another LED, starting at num LEDs, we subtract 1 and this L variable, which we've introduced to calculate the halfway mark. So number of LEDs minus I minus L. And because there's only 10 steps in here, we've made the delay go twice as fast. In other words, half as fast. By multiplying the length of the delay, we're making it go slower. Case 4 is exactly the same, except it's the other way around. So it starts off at the inside and goes outwards. You'll see what I mean, don't we? And then thinking about fairground lighting and disco lighting, and what other patterns could we come up with? And one of them was to light up the odd numbered LEDs or even numbered LEDs. And again, it does the same sort of thing. So in this one, it chooses to light up, and instead of incrementing I++ or I equals I plus 1, we increment by I equals I plus 2. So the first LED will be 0, the second one will be 2, the second one will be third one will be 4, then 6. So that's going to increment all the even ones. And then later on, we're going to add all the odd ones. And all we do is we add a 1 to make it start at 1. Same formula exactly, just offset by 1, so it will fill in the other LEDs. And we've changed it to a second random colour. Instead of just using the original colour and filling the unlit LEDs, we're going to fill them with another random colour before in that loop. There's a thing called train, which sets up an arbitrary number of LEDs and it sends them across. And the final one, I actually feel that it's good to have a pattern where no LEDs are lit. It creates a pause, it creates a bit of a visual effect where there's an expectation of what it's going to do next. So I've done a little thing that just sets them all to black again. And that is the whole program. Yeah, it's got quite a few things going on in it, but it's not complicated. So let's have a look at what it does. So I'm going to upload. And it likes it better if you put another flipping bracket in. It's because I'm copying and pasting from the actual program. So Control U to upload. And we'll see the patterns. And because they're random, that's the initializer. Because these are random, I have no idea which way they're going to go. So there's all sorts of random patterns on it. And for the benefit of those watching the program, we'll assume that you've now seen the basis of what it does. I'm going to put the brightness up to 100%. Give that a few seconds to upload, and then it'll initialize again, and you can see now it's quite bright. So there we are, we've got our patterns, and that's quite nice. But that's never enough, is it? 20 LEDs? I bought a roll of 600 LEDs. I don't plan to show 600 LEDs in sequence, but I'm sure we could do something a bit more interesting. So I'm going to set up another Arduino for you that I've already got set up on the bench, and we'll have a look at what that can do. Okay, so this is still a WS2812 LED, and it's the same Arduino. They haven't reprogrammed it, only to change the brightness. So change the brightness back down to 10. We're still driving from pin 7, and we've got exactly the same data lead with slightly different colours on it, but it's the same lead, and it's being driven from a power supply at the moment. So I've disconnected this plus 5 volts lead off the Arduino. The Arduino is getting its power from USB. So all we need to do now is change a few variables to make life a bit more interesting. So as you can see, there's a couple of LEDs lighting up, and it looks almost inconsequential at the moment. The reason being that we're only lighting 200 LEDs. Well, we've got 256 to play with. So if I change that to 256, not changing anything else on the program at all, we can now upload again. And this will show you why I've invested in this thing. Now, it does fill quite slowly at the moment, because we've put a delay in of 50 milliseconds every time it addresses an LED. These accumulate over 250 LEDs and slow it down quite a lot. So what I'm going to do is take that to the fast delay out altogether. And I'll just upload that when it gets to the end. And now it should run a little bit faster. Now, this is only one way of programming these LEDs. Programming them sequentially with a large number of LEDs is inefficient. And one thing you will notice on all of these strips is they have an expansion connector that could go to another matrix, another strip. So we really need to find a faster way of programming these when we're using a lot of LEDs. And I'll address that in another episode. I have done some testing of it, but I need to be totally happy. It's also part of another little project that I'm doing. I won't go into it now, but it's to do with video lighting and photography. I want to make something out of several of these panels, but that's all I'll say for now. I want it to be a little bit of a surprise. So you can see now that that pattern is nice and clear. It's always difficult to get it to show properly under a camera. But if I hold it up, you can see the patterns are flowing across and absolutely lovely. Again, because of the brightness of it, all the colours tend to look the same. I can promise you this is incredibly bright. I tested it on a mobile phone app, and when it's on full, one panel running off 5 volts It's kicking out 25,000 lumens, if you can believe the app. I've yet to compare that with a photo flood, because it's going to replace the photo flood. But we're going to be using several of these, and we're going to be doing some other interesting tricks with them. There's a number of reasons why I want to use these panels. But that is that, and just to finish off with, I'm going to put it on 100%. Press Control and U, and that will update. And let's blind the camera completely. So all these 6 patterns are now going crazy, and it's so bright. It's absolutely adding to the room lighting. I won't say it's lighting the room up. It's certainly lighting the ceiling up. And these patterns are very subtle. I've not made them harsh, reds, green and blues. You can play around with these variables. You could reduce it to 8 colours or 4, and you could have some really vivid patterns going. The whole point of my projects is that you can play with them and you can make them into what you want. You don't learn a lot of programming by just copying other people's data, but you do learn by modifying it. I hate the word hacking, but go ahead, hack the program, modify it, do what you want. You know, it's just an off-the-shelf program. I took some of the ideas off other people. A lot of it is the fast LED GitHub example programs with a few changes. Oh, that was the other thing, of course, is that there is the fast LED has a GitHub. So if you know what GitHub is, it's a place where you can go and download not only the library, you can download README files which explain how to use it. There's coding examples, and there are a lot. There are about 15 or 20 programs that you can then change, make them do what you want them to. And literally just by changing this number here, you can make it work with about 6 or 7 different chipsets. WS2812 is also known as NeoPixel. So if you see a NeoPixel display, sometimes these matrix ones are called NeoPixels. But check them out. There's WS2811, which is a slightly older one, and there are some newer ones which I believe are addressable faster. I have checked the specification for this particular LED chipset, and it's supposed to accept data at 800 kilohertz, so just shy of a megabit a second. For the technically minded, it requires an 8-bit red, an 8-bit green and an 8-bit blue being sent sequentially, followed by a 50 microsecond period of no activity. That is how it distinguishes, that's how it refreshes itself. And I'm wondering if the Arduino can go fast enough, because these things run at either 10 or 16 megahertz on the clock of the CPU, but it may not run these address buses as these data buses as fast. So what I did invest in, if I can put my hand on it, for a future episode, I got this. And this is an ESP32, and I haven't even undone it. And the ESP32 can do a few tricks. Firstly, it can run up to 240 megahertz. So that's the CPU clock, not the data bus. But also it's got Bluetooth enabled. So that means we may be able to control these panels from a mobile phone app. And I know you can, because I've seen it done. So there are a few other YouTube videos on the subject which are good to explore. It's always happy to get another opinion, but I'll be doing another project for that in due course. But that's all for now. I hope you pass comments on the videos and what sort of things you'd like to see using these, because I'm quite happy to build some projects, particularly involving LEDs, Arduinos, Raspberry Pis. What would you like to see? I mean, I want to keep it fairly simple, because I want people to get used to doing programming themselves rather than just copying and pasting, because anybody can do that. It doesn't really teach you a lot about programming. But I hope you have fun with it. Please subscribe and tick the little bell, then you get notifications when I put a new video online. And don't forget, get your Compilect box gear from compilectbox.cottoncart.com, which is a UK company. But they'll ship anywhere in the world. Get your merchandise, and you can look as cool as me. See you next time. Thanks for watching.